Why did you want to be a cosmonaut?
I'm not sure that my story is as romantic as many of my colleagues have. My mother states that I really wanted to become a cosmonaut since childhood, but I'm not so sure about it. It seems to me that I always dreamt of being a fighter pilot. But I do remember a couple of funny stories which somehow related with the cosmonautic from my youth. For example, when I was a high school student, I remember during one of the lessons, our class was given a task. So boys and girls were combined into couples, and so we were like a families. And the task was to develop a family budget. And to do this, everyone decided that he is going to be an engineer, teacher, somebody else. And I said that I was going to be a cosmonaut. From one hand, it was a path of less resistance, because I decided that the salary of cosmonaut is 10 times as much as the salary of engineer, and was interesting because nobody knew the salary of the cosmonaut, but the expectations were that it's rather high, and because there were no limitation that you cannot choose certain professions, actually it was correct. But on the other hand, it was a way of thinking, maybe a flexibility of thinking, because instead of solving a difficult task, you can just simplify your task and then trying to solve it. So having 10 times as much salary as my colleagues had, I decided my wife is just a housewife, she doesn't have work at all, and even with that we have enough money to do all necessary purchases and to have a saving. And one more story I remember happened when I was a student of military school, and when I became a student of military school, the first a month and a half we spent in a field camp, and we were taught how to take part in war as infantry. So we were crawling on the ground, we were digging trenches, we were running in gas masks with some machine guns behind back. And after a couple of weeks of these military exercises, one of the students immediately realized that it was not a military school which prepared cosmonauts, but only fighter pilots. Somebody must have told him that this is the truth. And halfly this is the truth, because we do have many graduates of that military school who ended up in Russian Cosmonaut Corps, but usually it was just a school for fighter pilots. And I definitely knew it, and I went to the fighter pilot school and I graduated from it. And only after more than 10 years I discovered an opportunity to try myself as a cosmonaut. And I decided to try, and so that's why I'm here.
Let me ask you to tell us a little bit about where you grew up and where you came from. Tell me about your hometown and what it was like for you growing up there.
I was born in Irkutsk, which is one of the largest cities in Siberia. The current population is about 600,000 people. It lies on the banks of the Angara River, which is the only river which flows from Lake Baikal. This is an industrial city, and when I was young, I remember that I attended many sporting groups, many studies groups, and everything was interesting for me. And I was fond of wrestling, boxing, volleyball, many other things. And because I have always dreamed of being a fighter pilot, I thought that it would be the right step for me do to a skydiving club. At that time, it was the only sky-related activity available for me. We didn't have at the time an opportunity in my city to fly any kind of airplanes. So I did my first jump when I was 14, and by the way, my son did it at his 12, and so I became a sportsman. But doing that, I had to didn't attend school. I had to miss my school lessons when I was at the drop zone, and when I was at high school, my high school had majoring in math, and it happened that our math teacher was a mentor of my class, and she was less than happy about it, and because of this, my relation with her sometimes were tense, but we had to find a common ground. We tried to coexist. Sometimes it was not easy, and usually at high school we had 11 hours of math a week, and even without putting any efforts to study this subject, upon graduation from the school I felt myself quite confident in it, and only later, when I grown up, I understood how right my teacher was, that she insisted me to attend the lessons instead of going to the drop zone.
Well, tell me about your education from after high school and as you went on. Tell me about your education and your professional career and the steps then that led you to become a cosmonaut.
Because I have always dreamed of being a pilot. I tried to attend military pilot school, but my first attempt was not successful. So 1 year I spent being a student of Polytechnical Institute in Irkutsk, and I was majoring in aviation design. Frankly speaking, I was not a good student. Because I definitely knew that I will do my second attempt to become a pilot, so I considered it like a step, which is not important. I just have to do something during the year because I cannot. I wasn't able to try to become a student of military school early than in the year. So I didn't put any efforts to study something. Because I was quite confident that my math is quite good and I can afford not to study it, and but I also didn't study any other subjects, and I finished my first term with almost all of the very bad marks, and I remember that usually we have a first term ended in January, and my birthday is also in January, and I remember that I overslept one of my exams, and it was the first exam after my birthday, and when I came to the exam, a student of my group was waiting for me with a toy, with soft toy, just to congratulate me, and seeing that the teacher who examined me, even though I did really bad, but knowing that it was my birthday, she decided to give me not 2, but 3. And when I was a student of aviation department, I, together with the other students, took part in construction and building paragliders. It was really interesting, and I got having experience in skydiving, and that we did these devices by ourselves, and we trying to fly. And I remember my first flight. We were taught how to fly paragliders on the field, and this is really right technique. You're just running with paraglider and trying to balance and trying to keep the right angle of attack. And when we became quite familiar with that, we were allowed to try ourselves from very little hills. And for the first time when I flew, the hill was maybe just 15 meters high, but I really did feeling that I fly. It's really interesting. It can be compared with the feeling you experience when you're a skydiver. It was something completely new for me.
So did you try again for the military school?
Yes, my second attempt was more successful, and I became the student of this military school. And I don't know why, but I chose a military school. At that time, in the former USSR, we had 3 military schools which prepared fighter pilots for the Air Force, but and I chosen maybe the most distant one from my house, so I had to travel all around the Soviet Union to another part of it, but it didn't matter.
So is that, keep telling me the rest of the story. So you go to the military school, and then what happens?
And then I became a pilot, and at the same year USSR collapsed, so it was, I think, really the worst time to grow in as a pilot. I flew to fighters, MiG-29 and Su-27, but I was not satisfied. I was not satisfied because I didn't have chance to get as much experience as I wanted. So at a certain point I decided to quit army service, and I went to one of Moscow universities with majoring in economy, computer science and math. And I graduated from it in 2003, and it happened that during just 1 week I got my diploma, and I was assigned to Russian Cosmonaut Corps. So I had to defer a career of software developer, but that's why I'm here.
And you were still in the military when you went to the university in Moscow to study?
Yes, but I studied it I didn't present at the lectures. I just went to the university to have my exams. I studied it by myself.
Now you, as you said, you become a cosmonaut and you're preparing for your first flight into space, and that's a job that comes with some risks that are associated with it that most of us don't have in our lives. So the question would be, why do you do it? What do you think that we're learning, Anatoly? What do we get as a result of flying people in space that you feel makes it worth taking those risks?
I do believe that the work cosmonauts and astronauts do in orbit is important for our life on Earth, because scientific research they conduct really helps to push our science forward. And station is a unique environment when many researches can be done. We really don't have this opportunity on Earth. For example, you know that we grow crystals on orbit, and we are able to get big 3-dimensional crystals, which is impossible here. And this is a way to understand deeper physical processes, and finally it helps to improve life on our planet. It helps to develop treatment from diseases. It helps us to develop new materials, and you know that many solutions which were created and which were intended for space now became widespread. This is why I think it's important for me. I'm really looking forward to feel myself as a part of the big scientific team who conduct experiments which will make life on our planet better.
You're getting ready to launch to the International Space Station to be part of expeditions 29 and 30. Anatoly, give me a summary of what it is that you're going to be doing on this mission, and particularly what your job responsibilities are going to be on this flight.
The launch of our Soyuz is scheduled to be on the 22nd of September, which is earlier than it was expected because first we knew the date of launch as the 30th of September, and this is one of rare cases when the launch date had been shifted to the left, not to the right. We start at 7:34 Baikonur time, and we dock the station the 24th of September at 2:19 GMT. During our mission, we are going to meet progress 44 and 46. We expect upcoming crew with Oleg, Andrei, and Don at the beginning of December. And we are going to have visiting vehicles which will be docked to the US side of the station, but the situation with them doesn't seem to me as stable, because just a couple of weeks ago we were told that we expect Dragon, Cygnus and HTV, but the latest information I've heard, we still expect Dragon on the 9th of December. We expect Cygnus on the 28th of February. We do not expect HTV any longer, and if we happen to departure from the station with a little bit later than we expect it to be, we would see ATV, but we won't. And talking about my role in these increments, really nothing to boast about, just generic responsibilities of flight engineers I use in the station.
Give us a sense of what that is. What does a generic flight engineer do on the International Space Station? What are your days like?
I think that my day will consist of scientific research and maintenance of station in proper conditions. Of course, we have time for sleep, we have time for meal, and if I'm not wrong, 6 times a week, cosmonauts and astronauts have physical exercises in their schedule, and it takes 2 hours a day. And when we have visiting vehicles, we focus on our activity on docking and redocking. This is just a common view of what I'm going to do when I'm in the station.
This flight is your first trip to space in your career as a cosmonaut. What was it like when you were informed that you had been selected for this flight?
First of all, I would like to mention that since we have a concept single float to launch, usually first cosmonauts as well as astronauts are assigned to be a member of backup crew, and when they went through this path, they are assigned to be to the primary crew, and I happen to be assigned to be a member of backup crew 3 times, and 2 times I have finished the program of being a backup crew completely. And actually, when you have spent several years being a backup crew, it is not so unexpected as it could be. Maybe the most surprise for me was when I was assigned to be a backup crew member, because you know, when we start international space station programs, we used to fly for a long period of time, three crew members crew at the station, and it was really difficult to become a member of the crew. But since we have a crew of 6 persons, it makes our life a little bit easier. The chances to be assigned are higher. So somehow I'm here.
Just what is up there right now? Give us a verbal tour of the International Space Station today.
International Space Station is without doubt the largest artificial satellite has ever orbited our planet. It's the most complex space station, and I would like to emphasize that it is International Space Station. And today we have a very complex object which consists of 16 modules made in different countries, and we have modules devoted to research, to physical training. Some of the modules are used as storage. For example, for labs, we use service module, we use small research module 1 and 2, US lab, Columbus, GEM as laboratories, and we use FGB, MPLM and GPL as storage facilities. And I would like to mention that we have Note 3 where we can find beautiful equipment for physical exercises as advanced resistive exercise device, which is really important. And my feeling is that Note 3 is like a space gym, and we have a very unique module, cupola, which provides a beautiful view to the planet beneath you. Station flies at a height about 400 kilometers, and its dimension, it has wide 109 meters and length 51 meters and height at about 20 meters, so it's a really huge object.
And we can see it without help of a telescope from the ground.
It's possible if you know where to find.
If you know where to look. Most of a lot of the modules that you've just described are there to support the science research, which is the main object of the space station's being there. One primary area of that science has to do with finding out how people can live and work in that environment safely. Tell us about some of the human life sciences experiments that you're going to be involved in during your 6 months up there.
Yes, we have a variety of life science experiments, and from rather simple ones, when you just take blood for the analysis, or when you keep a device which consists of accelerometer and a small computer in your pocket close to the heart, and when you sleep it measures acceleration and reads the data, and it allows scientists to understand how will you sleep, how did you behave while you were sleeping. And we have also quite complex experiments. For example, one of the researchers is devoted to determine how human body can withstand with gravity forces. You know that there is no gravity forces in the space, but we do have it on Earth, and we know this like orthostatic stability. When you keep your body upright, being on Earth, and because of gravity forces, your cardiovascular system has to resist to gravity forces to keep your blood running. And when we are under conditions of microgravity, our body understands that something goes not as it was on Earth, and it leads to muscle atrophy, it leads to bone loss, it leads to our cardiovascular system becomes less ready to return to ground, to Earth conditions. But it's really important because even if we are going to spend half of a year on Earth orbit, after the period of time we are going to return back, and it's really important to be ready to meet with conditions of our planet. So the experiment I'm talking about allows to decompress lower part of your body, to decompress air around lower part of your body. So it models the conditions of gravity on our planet, and depends of the level we reduce pressure, air pressure in the lower part of your body, we can model different levels of loads for your cardiovascular system.
Different strengths of gravity.
Different strengths of gravity.
And this is also, I can see, is also would be important for a trip to the moon or to Mars, where after a long trip you're going to have to get out and do work and need to be strong.
Yes, we do. And while we perform this experiment, scientists on the ground take data real time about our blood pressure, about how our heart works, about several more parameters. And one more experiment devoted to study of human body. The name of this experiment is typology, which can be translated as typology. The task for this research is to understand how can we improve ability of cosmonaut to take part in different types of operator activities under the statistically distributed and determined irritants. And this experiment consists of two phases. The first one is done immediately before flight and takes usually might be a couple of weeks to collect data, and then you do the second phase being on orbit, so the scientists have ground to compare with. And to perform this task, I, as an operator, will play computer games. So maybe this is going to be my favorite experiment I'm going to take part with. And I remember that when I bought my first personal computer, these devices were not widespread. And it happened that a computer game was pre-installed to my device. So I began playing, and I found it interesting. And I had been playing for 2 or 3 days with just short periods for having a sleep and for meal. And one day a neighbor of mine came to my place and he asked to read a data from diskette. At that time, people transferred data from machine to machine with diskettes. It's difficult to believe, but it was. And after that, I found a virus on my machine. And it was an important moment because I was not able to continue gambling, and because my machine didn't run at all, I had to stop and to begin finding a solution with this problem. And it somehow attracted me from this computer game, but I understood that I'm I'm a gambler. So, could you imagine another job when during your work time you play computer games and your employer pay you for it? That's what I'm going to do on orbit.
And as you said, this is in order to test your reactions.
During these experiments, sensors are put on the head of operator, and actually they take readings of what is going on in your brain.
Well, many of the experiments that you just described you are being the subject. People are taking data from you. For many other science experiments that will be on the station during your time there, you will serve as the operator and the assistant for scientists on the ground. These are experiments that are in a lot of different kinds of science research. Give me a sense of the range of the different kinds of other experiments that you'll be working on.
For example, I'm going to be engaged in experiment Rusalka. The name of the experiment can be translated into English as mermaid. This is research devoted to getting data about the level of greenhouse gases, carbon dioxide and methane in Earth's atmosphere. To perform this experiment, I will use a Rusalka tool, which is an assembly of camera and spectrum analyzer, and we use sunlight to get data. And during the previous phase of this experiment, this tool has been adjusted, how to say, it takes basic readings when it was directed to sun. So we have sun spectors in this device, and now when we get light reflected from Earth's surface, water, sometimes from clouds, we can derive useful information from it. So my task as an operator is going to be to find sun glint, and the time when the sun glint can be observed and the position, its position in the window, can be predicted using special software. So the task for me is to catch the sun glint, and during a certain amount of time to track its position. And when the camera takes the aim, the spectrum analyzer reads all the data in the necessary range, in the desired range. And later the data is transmitted to the Earth for analysis. And this experiment is important because it will help to understand the locations, how greenhouse gases are distributed in our atmosphere, and it will. Usually, I talked with developers of this experiment, and I was told that this tool is just a previous step for designing a new one, which will be more complex, which will have higher spatial resolution, and which will be operated in automatic mode. And the task for that tool is to get more data and to do the map of distribution of carbon dioxide and methane and in Earth's atmosphere. But what we are doing now, we are just testing the technologies and the procedures that will be used in the new one device. And having this data, scientists will be able to understand better the processes in low troposphere, which is very important to understanding the changes in the climate of the Earth.
That's a good example of one of the other kinds of science, and as we said, there are several others. There's even some science that goes on the outside of the station. There's a spacewalk on the schedule for later on in your increment, and I understand that part of that is going to involve two of your crewmates going out to change out some experiment samples out there. Tell me what the plan is for this spacewalk that comes up later on in your time on orbit.
Correct. Closer to the end of increment 30, we are going to have a spacewalk from Russian side, and the number of spacewalk coincides with the number of the increment, which is interesting. And Anton and Oleg are going to go outside. The tasks for the EVA are to install a protective meteorite shield to external SM surface, and to conduct two experiments, выносливость test. And I would like to point out that the test, the выносливость, the name of the experiment can be translated as endurance, is a brand new one, and Anton and Oleg will take a unit and transfer it to MRM2. The unit consists of two trays, and each tray has metal samples of different metals. And these trays will be exposed on external surface of MRM2. And for the first tray, the time of exposure is 1 year, and for the second one, it's going to be 3 years. And after that, on Soyuz, these samples will be returned to Earth for studies. And the importance of this experiment is that today, when we have significant growth in space machinery development, we not only need new space systems of new generations. We also need new materials devoted for space. So exposing these material pieces in real space conditions, in the same conditions as usually the modules are, and I would like to mention that these samples will be exposed subjected to loads and not subjected to loads, which is a novelty of this experiment. And it will help to understand how space environment influences mechanical properties of these materials.
The spacewalkers, your crewmates, are going outside. Do you have work to do on the inside of the station to assist them during their spacewalk?
I may, because usually assisting to crew members who go outside is not a difficult task, and I think that any of my crew members can do it. Usually we have it as a part of generic preparations of cosmonaut to space flight, the training in conditions of Hinder lab, and we have special simulators in GCTC which allows to perform certain steps of EVA, and this generic preparation, I think, will allow me to assist if needed.
You mentioned earlier on that during your time on orbit, you're expecting visits from a variety of different kinds of supply ships. There are, excuse me, There are supply ships coming to the station now from Russia and Europe and Japan, and there are some new cargo ships being developed in the United States under NASA's Commercial Orbital Transportation Services program, and they have test flights that are coming up. Tell us a little bit about these new vehicles and how they mix in with those current ships to keep the station supplied.
Well, we do expect visits of SpaceX Dragon and Orbital Sciences Cygnus. These brand new vehicles are designed because I think NASA decided that there is a way to supply stances and do it cheaper than shuttle used to do. So, according to contract, two commercial companies which won at the competition develop their vehicles, and first we are going to meet Dragon, and Dragon is a spaceship developed to carry cargo as well as in the nearest future a crew to the station, and it can deliver up to 6 tons of supplies to the station, and what is important, it can return to Earth up to 3 tons of supplies, and if it will be, when it will be a manned spaceflight spaceship, I think it will be able to carry up to 7 astronauts, and I've heard that the plans for this vehicle is not only a supply station on the low Earth orbit, but also to go deeper to the universe, to reach Moon and Mars. And Cygnus is a vehicle which is focusing, my feeling that is focusing exclusively on delivering supplies to the station. It can carry up to 2.7 tons of payloads to the station. It cannot deliver something, it cannot deliver anything back to Earth, but it can trash up to 1.2 tons. And because shuttle has retired, but we still have a variety of vehicles which will supply station. We have Russian Progress, we have European ATV, Japanese HTV, and plus 3 of these vehicles we are going to have Dragon and Cygnus. And I've heard an estimation that all of the fleet of all of these vehicles is able to provide all necessary supplies to the station, and to achieve it required at least 6 flights a year of both Cygnus and Dragon.
It must be it would be interesting and exciting to be there for the first flights of new vehicles.
Of course, yes.
Having commercial cargo ships that are going to the space station is a big change in the spaceflight program over the 50 years since Yuri Gagarin flew by himself in a small capsule. You and your crew are going to be the first ones to launch since the space shuttle completed its final mission. What do you think about the space shuttle's contribution to the to human spaceflight and to the International Space Station?
I do believe that space shuttle is a milestone in space exploration. During his 30 years of service, this vehicle delivered a great amount of satellites to Earth orbit, and it would be difficult for me to imagine how International Space Station would look without the space shuttle, which delivered all of the modules from the American side. And when I was young, I dreamed of flying Russian shuttle Buran, and you knew it did its one successful flight. Unfortunately, after that, USSR collapsed, and we were not longer able to continue this program. And I would like to say that a space shuttle is just looks beautiful. It's a really great machine.
Well, that's an era of the human spaceflight that is now ended. But I want to ask you to look ahead in the next 10 or 30 or 50 years. Where do you think human spaceflight is going to be then? And how is the International Space Station helping prepare us for that future in space?
Well, it's not easy to imagine what will be in 50 years. When I was young, I used to read a lot of books, a lot of scientific
science fiction books.
Science fiction books, and I love to read about other worlds, about spaceships, about aliens. Unfortunately, I do not longer have time for doing it. But my wife, she's really interested in everything which is outstanding, which looks like phenomena, which looks like a mystery, and she believes that little green aliens exist, and she really thinks that in Gagarin Cosmonaut Training Center we have special secret classes devoted to understanding how to communicate with these guys, and she thinks that communications with aliens is a part of everyday routine operations the cosmonauts have in orbit.
Is it?
So I think that in 50 years, the truth about green little aliens will be finally revealed, and my wife will still be angry at me because I don't share this information with her. Speaking more serious, I think that, of course, human beings are too curious creatures, and they will not remain for a long time on low Earth orbit. They will go further and further to the universe. And the International Space Station we have today is the right place to prove solutions we already have. Because to go further, we will need new solutions, new materials, new spacecrafts, and the existing solutions should be proved in the International Space Station. And there is a unique opportunity if we have a malfunctioning equipment which do not operate any longer, and we can deliver it to Earth so the designer can understand what was the reason behind this malfunction. It will help to do our equipment more robust, which we will need for the long-term space flights. And I really believe that travel to another planet will be an international undertaking, and the experience we have on the station now is also very important. Is also a very important step towards this, because we learn how to work together, and we understand how effectively we can be combining our efforts.